Today we are going to find out how salts interact with water and how that can change the pH of what you thought was a neutral solution as we go through these points. And remember, download your copy of this PDF so you can be making your own revision notes as you watch along. So, first up, what is salt hydrolysis? So, it is a reaction between a salt and water. So in a neutralization reaction, you are making a salt and water. And you would assume that the pH of the solution would be 7. However, this is not always the case, as we need to think about the potential conjugate acid or bases that are formed. And yeah, when they react with water, this is called salt hydrolysis. And this is going to make so much more sense when we look at some examples. So let's look at some equations. So with a strong acid and a weak base, we could get ammonium chloride as our salt. Strong acid, weak base, giving us ammonium chloride. But in a solution, in an aqueous solution, these guys aren't hanging out together. They are splitting up, or they just stay split up. They never even come together. So in our aqueous solution, we have the two ions. We have the ammonium ion and we have the chloride ion. And now what we need to do is we need to think if they're conjugates, so that's plus or minus a hydrogen ion, can form, and if it can form, is it going to interact with water? So with the chloride ion and water, nothing is going to happen, and that's because its conjugate is a strong acid. It is hydrochloric acid. Hydrochloric acid is not just going to form. So the chloride ion don't do nothing with water. However, the ammonium ion, so the ammonium ion, its conjugate is ammonia, and ammonia is a weak base. So this is going to form in solution. So this is going to set up a bit of an equilibrium, and yeah, we are going to get the hydrogen ion in that solution. So the ammonium ion is acting like a acid as it is donating a proton. So because of this, the pH of the solution is now, of this solution, is going to be less than 7 because of this hydrogen ion in existence. So now let's look at what's going on with a strong base and a weak acid. So these guys are going to react, and this is going to give us the sodium ethanoate salt. But just like before, these guys aren't hanging out, they're not touching. In our aqueous solution, we're going to have two completely separate ions. So we're going to have the ethanoate ion, and we are going to have the sodium ion. So if we look at the sodium ion first of all, is it going to react with water? No, it's not, because its conjugate is sodium hydroxide. So that is strong base, that's just not going to form. So we're getting no reaction. However, if we look at the ethanoate ion is going to react with water because it's going to form ethanoic acid, which we know is a weak acid because we've got it over here. So this is going to react with water, and it's going to form some hydroxide in solution. So because of this, the pH is going to be greater than 7. But now let's have a little look at what is going on with our other titration examples. So here we have a strong acid, strong base. Sodium chloride is the salt. We've got our two ions. Again, we've got the two ions in solution. These guys aren't hanging out. And we already know that this isn't reacting with water. This isn't reacting with water. So in this case, our pH is going to be 7. So with strong, the salt that's going to get formed doesn't interact with water, so the pH is going to be neutral. We are making a neutral solution from our neutralization reaction, just what we love. But our final example is a little bit trickier. So we've got a weak and a weak, and we know that both of these exist separately in solution, and we know that both of them react with water. So what is our final pH going to be? Well, it all depends on the pKa and the pKb values. So the lower the value, so if you've got a low pKa and a low pKb, that means you have a stronger, weaker acid or base. So that means more dissociation is happening. So if they have a similar pKa, pKb values, they kind of cancel each other out, and your pH is going to be around 7. However, if there is a big difference between the pKa and the pKb value, then the pH is going to go up or down accordingly. So this brings us on to our final thing, which is the summary table. So as we're already talking about a week and a week, so here we go. So if the pKb value is much greater than the pKa, you're going to end up with an acidic solution. If it's the reverse of that, the pKa is greater than the pKb, you're going to end up with a basic solution. And if they're around the same, then the pH is going to be around 7. And then yeah, just to summarize all the other things. So with the strong base, strong acid, we're getting a pH of 7. With the weak base and the strong acid, we're getting a slightly acidic salt. And then yeah, with the weak acid and the strong base, we're getting a slightly basic salt. So you can kind of think about whatever the strong is winning that battle a bit. So this is slightly basic because we've got a strong base. This is slightly acidic because we've got a strong acid. So that's like an easy way to remember this lovely summary table. All right, so thank you for watching. That is everything from me. And remember to tell all of your chemistry buddies about the channel. The more buddies you tell, the more videos will be made. All right, catch you in the next one. Bye.